All right, so guys, you should have gotten papers passed out to you from your lovely teacher. I got into a fight with the copier and lost, so I misprinted. So the papers, you're gonna put them back to back and then fold them in half, and it should make a little booklet that you're gonna follow along with. So you're putting them back to back, so you should have two papers that I passed out, and you're putting them back to back and folding them in half. You take it.
I'm gonna away.
No.
I don't know if it's
We'll go next. Let it drop. All right, and so back to back. And fold them in half. Like literally, with the papers back to back. That means the two plates touch each other. And then you fold it in half and you make a booklet. Okay, so absolute value function. Does anyone remember anything about the absolute value function? Anyone? Yes, absolute value makes positive. Nobody? All right. No one knows what the shape it looks like? Like a V. That's what we're talking about. Absolute value is our V-shaped function. Okay. So for absolute value, these are the key features of its parent function. So at the top of your notes, you're describing the parent function. That's where it starts at. And then from there, everything modifies, right? So for our parent function, we just have f of x equals the absolute value of x, okay? When x is positive, then the output's going to be positive. But also when x is negative, the output's also going to be positive. So if you look at the table of the parent function, if my input is -3, my output is +3. That's because absolute value is asking you about distance. How far is it from the origin, right? And distance is always positive. Just because I walk backwards, is my distance going to be a -mile? No, I'm just a fool who walked backwards for a mile, right? It's still a positive distance, okay? Next, we're going to look at the graph. As you can see, the graph is a beautiful V shape, okay? Absolute value, think about the V in value, okay? It's going to make a V shape. The V shape has some important things to take note of. Your vertex is going to either be your max or your min of your function. So it's either going to be your high or your low, okay? Your axis of symmetry is going to always be the X value of your vertex. It's the invisible line that splits your V into two halves. The two halves are going to be made up of positive and negative slopes. So for this problem, our negative slope is on the left and our positive slope is on the right. Okay, your domain, because the graph goes forever to the left and forever to the right, our domain is all real numbers. That means we go from -infinity to +infinity, right? Our range depends on our y value. What is your lowest y value? Well, our lowest y value here is a 0, right? And then it grows from there. So our range is y is greater than or equal to 0. We also can write that in interval notation, saying that we start at 0 and we continue to infinity. Your x and y intercepts are both at the origin, and that is the parent function. Okay, everything changes from the parent function, right? And that's what we're going to be doing. So we're going to be graphing. You are the graphing calculator, okay? So you're going to be doing the graphing without the calculator and just your hands and your beautiful brains, all right? So how do we do that? Well, there are two options. Option A is that when you have a absolute value written as a absolute value of x minus h plus k, it tells you everything we need to know in order to graph, okay? Your h and your k are your vertex, okay? Your h and k are your vertex. That's our starting point, right? That's where we split our function into the two halves. Okay, key thing to remember about your h's, your x's are liars. X's lie. That's why they're x's, okay? X is lie, meaning that even though it's like X minus H, it's actually a positive H. It's always the opposite of what you think. So if it said X plus H, then it is a negative H. Does that make sense? All right. You're going to choose 2 to 3 points to the left and to the right of the vertex and just substitute them in. You're going to plot the points and connect them. After we plot points, in order to connect them, we're going to follow the slope. Key thing here is to remember to use your slope. And then we're going to describe domain, range, axis of symmetry, and intercepts. Those are the things that you should be able to describe from the graph. Got it? All right, so we're going to do our first one together. Here we go. So we have, for example, A, f of x equals the absolute value of x plus 2 minus 3. First thing we got to identify is our h and our k. What is our vertex? What is it?
-2.
-2, -3. Remember our what are liars? X's are liars. Okay. So that is our starting point. That is going to be the center of our table. So we're at -2, and that's because it's the vertex, and its output is going to be -3. Now you're going to choose any 2 points to the left of -2. Where do we want to go for x? I'm just going to do -3 and -4. I'm going to choose 2 points to the right, which is going to be -1 and 0. After you choose those points, you're then going to evaluate into the equation. So we're substituting, right? So we have the absolute value of -4 plus 2 minus 3. We have the absolute value of -3 plus 2 minus 3. We have the absolute value of -1 plus 2 minus 3. We have the absolute value of 0 plus 2 minus 3. How do we feel about substituting in? Now we're going to evaluate to find our new outputs, right? Our output. So starting, absolute value, -4 plus 2. -2, absolute value of -2, 2. So we have 2 minus 3. So what is our y? -1. With me? -3 plus 2. -1, absolute value of -1. 1. 1 minus 3 is -2. All right, -1 plus 2. And absolute value of +1 is 1 minus 3 is -2. 0 plus 2. 2. Absolute value of 2 is 2 minus 3 is -1. So here are my points. I'm going to plot them. -4, -1, -3, -2, -2, -3, -1, -2, 0, -1. And it said we're going to use our what to finish our graph? Our slope. So the slope on the right-hand side is I rise 1 and run 1 to the right, right? Rise, run, rise, run. So we're going to finish it out by rising and running. On the left-hand side, I'm going to rise 1. I rise 1 and go 1 to the left, rise 1 and go 1 to the left. And pretend that your teacher went through all of the points. Okay, was it terrible? No, now we're going to analyze the function. So analyzing our graph. First, it says to state your domain. What is our domain? All real numbers, because the graph goes forever to the left and forever to the right. So from -infinity to positive infinity. If you want to be lazy, you can use the R. I don't know what my computer is doing. Excuse its weirdness. My range, your range is from bottom to top. What is my lowest point? My lowest point is what? -3. My lowest Y value is -3, and it continues forever. So it goes from -3 to infinity. And that's because Y is greater than or equal to -3. Yes? Axis of symmetry. Your axis of symmetry is going to always be the invisible X value that's divided into 2 halves at -2. And last but not least, it wants us to identify our intercepts. Intercepts are when do X and Y equal 0. Where's our intercepts? Where are our intercepts? Then we have one at -5, 0. Where else? We have 0, -1. And we have 1, 0. How do you feel about graphing and analyzing absolute value? Doable? Yeah? All right. So the next example I'm going to show you guys involves a fraction. And that's because a lot of times, oh, it's almost time for us to go, isn't it? A lot of times y'all freak out because there's a fraction, but does the process change? No. Okay, fractions are our friend. This is where we'll pick up tomorrow. Thank you for a great productive day.